Welcome to Stats Rescue 911. My name is Lynn, and today I'm going to take you through a chi-square goodness of fit test. We're not actually going to perform the test, but I'm going to tell you all the key facts about this test and what it's used for. All right, so the symbol used for a chi-square is this rather funny looking X with an exponent of 2. And just so that you know, we pronounce it chi and not chai. That's the T. All right, let's start with a few need-to-knows. It would be really good if you knew something about inferential statistics, what hypothesis testing is, and the meaning of significance. So if we say that something is statistically significant, it would be really good if you knew what that meant. That way you can make full use of the information that's going to follow in this little module. All right, so the chi-square goodness of fit test is a statistical test used in either of 2 scenarios. So there's going to be 2 situations in which a chi-square goodness of fit test might be appropriate. The first one is, I don't really have a name for it, but it's used when you have one variable. Notice how the word one is capitalized. So you have one variable with at least 2 non-overlapping categories, but typically fewer than 6. We'll talk about non-overlapping categories in a minute. The second thing is you have counted the number of people or things that fall into each category. Because sometimes we do research on animals, or we might do it on cultures in a petri dish, so we can't always say that we're counting people. And then finally, you are testing the hypothesis that the frequencies in each category are equal. Now, this may not make a lot of sense to you without an example. So let's look at an example. This actually came from a study that I did with my students. And we asked, among other things, we asked other students whether they love horror movies, like horror movies, and hate horror movies, or I should say, or hate horror movies. And we surveyed 58 students. And this was the breakdown of the number of people that fell into each category. So there were 19 people who responded that they love horror movies, 21 liked them, and 18 hated them. Now, by non-overlapping, we mean here that a given individual can only fall into one category. They can never belong to 2 or more categories. All right, now these frequencies are referred to as our observed frequencies. And the reason for that is because these are the frequencies we collected. These are the data that we have. These are observed, we collected them. Now, in contrast, we're going to talk about expected frequencies. Now, the expected frequencies are those frequencies that you would expect to see if, in fact, all the categories were equally represented. So, in other words, we can see that 19, 21, and 18 are different, but our question is, are these statistically different, significantly different? All right. So what we need to figure out is what should we expect to see in these cells if in fact the frequencies were equal. So if we have 58 students that we surveyed, and they are in fact equally distributed across the 3 categories, then we would take 58 and divide by 3, and then we would get 19.3 people in this category, 19.3 people in this category, and 19.3 people in this last category. So these are the frequencies that we would expect to see if indeed they are equally represented, so equal frequencies across the categories. Now, obviously, you can't have 19.3 people. The expected frequencies are calculated and therefore theoretical. So in theory, I suppose we could have 19.3. It is a horror movie after all. Okay, so again, what we're testing with this goodness of fit test is the hypothesis that the frequencies that we observed, the 19, the 21, and the 18, are statistically equal, right, to each other. We do that by calculating the frequencies we would expect to see if, in fact, 58 people were to be evenly divided amongst the different categories. So then the next thing we do is we run our chi-square contingency test. We look to see whether or not it is significant. Now, if it is not significant, so in other words, p greater than 0.05, or if you're using SPSS, it would be the sig value is greater than 0.05. This means that the observed frequencies are the same as the expected frequencies. There is no difference statistically between the 19, 21, and 18 and the 19.3, 19.3, and 19.3. So what does this mean then in terms of a conclusion? Well, if these frequencies are equal to each other, and these frequencies up here are the same as those, then by logical deduction, we can say that your frequencies are also statistically equal across the categories. All right, so again, if these are equal, that must mean, and these are the same as these, then these must be equal as well. So the reverse would be true if the chi-square were significant. If it were significant, then we would say that these frequencies up here, the observed, are different from the expected frequencies. And so we would then conclude that our frequencies are not evenly distributed. And then we would go on to say which category was the most represented and which was the least, etc. All right? Okay, now I did say that the chi-square test, goodness of fit test, is used in either of two scenarios. So now we need to look at scenario number 2. With scenario number 2, it starts off the same way. So you have one variable with at least 2 categories, but typically fewer than 6 categories. And these are non-overlapping. You've counted the number of people or things that fall into each category. But this time, you're testing the hypothesis that the frequencies in each category are the same as the frequencies obtained from some other distribution of the variable, whether that other distribution is real or hypothetical. Now, at this point, you probably need to reread this sentence a couple of times. You can do that. You can pause and read, but just follow along with the example, and I think that this will make sense to you. So let's look at an example. Go back to the horror movie study. All right. So recall that we found out of 58 people, 19 love them, 21 like them, and 18 hate them. All right. We might ask ourselves, well, what is it like nationwide? All right, so what percentage, for example, what percentage of people love horror movies, like horror movies, and hate horror movies? Now, I don't exactly know where we would go for this information, but let's pretend that there is a National Bureau for Horror Movie Statistics. It is hypothetical, but we're just, playing along here. All right, so we call up the Bureau, and we ask them what percentage of people nationwide love, like, and hate horror movies. And they respond to us that approximately 34% of the population loves them, 43% like them, 22% hate them. All right, so now we have the percentages within each of those categories. But remember that we need the frequencies out of 58. So in order to get the frequencies out of 58, because we want to know what would that look like in our sample, you have to take the 34.5% and figure out what would be 34.5% of 58. All right. So essentially what you do is you have to move the decimal point over 0.345 times 58, and you get the frequency out of 58. Okay. So 34.5% of 58 is 20. 43.1% of 58 turns out to be 25, and 22.4% of 58 turns out to be 13. All right, and again, you just move the decimal over 2 places. All right, so you get 0.224, multiply that by 58, and you get your 13. Okay, so now we know, because of what the National Bureau of Horror Movie, statistics has told us, that this is what we would expect to see in each of the categories based on their data. Now our question becomes, is our distribution similar to the one reported nationally? All right, so is 19, 21, and 18 statistically the same as 20, 25, and 13? So we're going to go ahead and we're going to run the chi-square chi-square goodness of fit test. And if it's not significant, it means, once again, that our observed frequencies are the same as the expected frequencies. All right, so there's no difference between this distribution and that distribution. So what can we conclude? Well, again, if it's not significant, it means that our distribution is distributed the same way as this distribution. All right, so again, the distribution of people who love, like, and hate horror movies in our sample is the same as statistically as what we would expect to see in the population. All right, well, that's it. I hope this helps.